In each of the 4 examples we are about to do, we are going to be asked to write a formula that expresses the nth term of the geometric sequence. So we are not adding these up like the previous problems. We're going to do one at a time, so we're going to start with this first one. If you haven't had a chance to write them down, you will have a chance shortly. Okay, similar to the last one, just recognize this is a sequence. It's a list of numbers. It's a list of numbers, okay? Keep that in mind, a list of numbers. Okay, we're going to start by identifying the first number. So in this case, A is equal to 40. Okay, and then we need to know what the rate is. To get the rate, we take the second number and divide it by the first number. 20 divided by 40 reduces to 2 or 4, which is the same as 1/2 or 0.5. That's all the information we need. Now we can write, you can start with y equals or a sub n, however you preferred it. Y equals 40, and actually it says to write a formula. I'm going to write it 2 different ways, and you get to write your preference. Bless you. That's one way to write it. Or that's another way. Depending if you like x's and y's or a sub n's and n's. Your choice. So I'm going to show you how this works right now. If you needed a little reminder, when you take a number and raise it to the 0 power, the answer is always 1. That's just a little reminder first of all. Okay, let's do this. Do you agree this is the first number in the sequence? So when I substitute a 1 in, 1 minus 1 is 0. So any number raised to the 0 power is 1, and 1 times 40 is 40. Okay, let's do the second number. 2 minus 1 is 1. 1/2 to the first power is itself. It's 1/2. And what's half of 20? Oh, what's half of 40? Okay. Doing the third number. 3 subtract 1 is 2. So can you take 1/2? So type in 0.5 into your calculator, which is an equivalent decimal, and please square it. Then take that answer times 40. Do you get an answer of 10? Okay, this is correct. Now, whether you use the a sub n or you use a y and an x, it's totally up to you. Okay, next problem, we have a list of numbers. It's a geometric sequence. First number is 3.2. Bless you. Then to find out the rate, take 6.4 over 3.2. Please divide. And you have an answer of 2. I'm going to use a sub n this time. So a sub n equals the first number times the rate raised to the n minus 1. Let's figure out if the third number would work. So if I substitute in 3, representing the third number, 3 minus 1 is 2. 2 squared is 4. Please take 4 times 3.2 and see if you end up with this number. Please take 4 times 3.2 and see if you end up with 12.8. Okay, next one. First number is 50. To find out the rate, I'm taking 15 divided by 50. Let's reduce that. Take 15 divided by 50. And whether you write a 0.3 or you write a fraction, it's totally up to you. There's my rate, and there's my first number. So I can use a y this time if I want. Y equals the first number times the rate raised to the x minus 1. Let's do the same thing to ensure we're getting this right. If I plug in a 3 representing the third number, 3 minus 1 is 2. Can you guys please take 0.3 and raise it to the second power? Get an answer and take it times 50. Is it 4.5? Okay, with your partner, please do the last one. your level of understanding right now? Excuse me, 1 to 5 on a hand, 1 to 5. Your level of understanding. So majority of us are 3 and above. Let's take a practice problem without the help of your partner, giving you 2 minutes to finish it, and then we'll go over it. On your own, please. You're not asking to find the sum, you're being asked to write a formula that represents this geometric sequence. You can't see it. There we go. I want to reiterate, Mari asked a great question earlier, and it was, should I round a fraction into a decimal? Do not round, do not round. Whether you write them as a decimal, whether you write it as a fraction here for the 0.5, doesn't matter. 2/3 you can't write as a decimal because you'd have to round then, okay? Can I have right now a thumbs up or thumbs down based on your understanding? I just need to see where we all are.